Rain1290 with you to bring you another risk analysis for July 24th, July 25th, 2025. So we do run the risk of strong to severe thunderstorms for the late evening of July 24th specifically into pre-dawn July 25th. So this plot represents the total amount of instability that's taking place, in this case right around the mid-afternoon of July 24th. So this is measured in joules per kilogram, and the brighter the colors, the larger the amounts of CAPE. So the greens, especially the yellows to reds, represent the highest values, and we're seeing that distribution of high CAPE, moderate to high CAPE, southern Quebec all the way southwest towards southwest Ontario. So we're seeing values as much as 3,500 joules per kilogram in southern southwest Ontario and even towards southern Quebec. So we're still seeing values getting close to 2,000 joules per kilogram across much of southern Quebec, even up to 3,000 just north of the Island of Montreal. And then that starts to increase towards the Island of Montreal to some degree. Okay, so previously we looked at convective available potential energy, which is CAPE, and we want to see where those values are coming from. So one of the best places to start is the mid-level lapse rates. So this actually shows us how quickly temperatures are decreasing across a slice of the mid-altitudes of the troposphere. So the brighter colors represent the steepest rates. So in this case, we don't have particularly steep rates. So we're starting with 2 p.m. on July 24th, and we want to check later in the day on July 24th and going into the pre-dawn period. And really, we're not seeing all that much. I mean, these gray colors represent marginally steep rates of about 6 to 6.5 degrees Celsius per kilometer, but we're not really seeing all that much across southern Ontario to southern Quebec. So our CAPE is largely guided by other factors. So let's take a look at those other factors. But I will say that we do have some patchy 6 to 6.5 Celsius per kilometer rates taking place, including around the island of Montreal, actually. So this could be a little bit of a boost for instability around the island of Montreal and southern, southwest Quebec in general. And patches exist also in southern to portions of eastern Ontario and a portion of the Northeast, especially in the Northeast, actually, in Vermont to New Hampshire and much of Maine. And then, of course, going into pre-dawn, we're not seeing all that much. In fact, they get a bit worse. So really, mid-level lapse rates aren't offering that much of a contribution throughout the forecast period. In terms of low-level lapse rates, as we go forward, we want to look for those brighter colors, and we're actually seeing that take place by the time we get to the mid to late afternoon period. So let's look back at 2 p.m. So it's already quite steep, which is representative of the amount of solar heating that is taking place here. So we know we're receiving a lot of sunshine during the afternoon of July 24th, and this will keep instability high going into the evening and into the pre-dawn period. Okay, now quickly looking at our dew point temperature. So this is representative of how high the humidity really is. So the higher the humidity level, the higher the dew point, the higher the amount of moisture content in the atmosphere. So really what we're looking for are these purples, these hues of purple, even the blues, they represent high to very high humidity. And really what we're seeing throughout July 24th is very high humidity occupying southern Ontario to southern Quebec, much of the Northeast. And this is going right into the late evening right now of July 24th and then going into July 25th. That stays with us into pre-dawn. Okay, so we know a cold front is also at play, but we want to assess how strong that cold front really is. So one place to do that is through surface moisture convergence measured in grams per kilogram per second. So the units are not that important. What we need to look at are the brightest colors, which represent the highest amounts of surface moisture convergence. So let's go further in time throughout July 24th. Right now we're at 2 p.m. of July 24th. So let's go further into the mid-late afternoon period, into the early to late evening, and we're starting to see this area of pretty large lift that's taking place is represented by these reds to purples, even blues along that cold front as it slides to the southeast. So we're seeing this area that's really looking healthier for lift as we go into the late afternoon. So this is around sunset and going towards the later evening, and then that starts to slide farther south. But you do see large amounts of this still sticking with us into early to mid pre-dawn. So this is 2 a.m. in the morning right now, and we're still seeing that area of stronger lift in southern Ontario, well, eastern Ontario mostly, to southern southwest Quebec, and then much of New York, central New York actually, and then going northeast towards Quebec City. Okay, so here we're examining lift at approximately the 500 millibar altitude in terms of vertical velocity. This is measured in microbars per second. So again, just like surface moisture convergence, we're looking for the brightest colors, which is representative of the highest amounts of vertical velocity or lift. So really what I'd like to bring your attention to is this potent shortwave trough that's accompanying the cold front that I showed previously. And we're seeing that as we go deeper into July 24th. And as you see, these brighter colors starting to really emerge across southern Ontario, and especially going to eastern Ontario and parts of southern Quebec. You're seeing this area of pretty strong lift that's taking place along that shortwave trough. And then going into late evening as it slides into upstate New York. So here's a sounding for the late evening of July 24th. So this is specifically around 11 p.m. for the Montreal area, so the West Island of Montreal area specifically. So that's our reference point here. So just a few attributes I just wanted to go through very quickly. Let's look at our wind field distribution throughout the troposphere, and what we're seeing is some really strong wind profiles that are taking place, including at the surface. We're seeing a strong southwesterly flow taking place during the late evening. Now, I think this will start earlier in the evening, late afternoon into the evening period altogether. So we're seeing a strong southwest flow, and then this becomes westerly by the time you reach the 850 millibar altitude, so about 1.5 kilometers above ground. So really what we're seeing is a fairly good veering component that's taking place within our boundary layer, and then that stays pretty strong right throughout the troposphere in terms of a unidirectional shearing field. And look at our 500 millibar. So this is 500 millibars. If you follow it all the way to the right, we're seeing some pretty strong westerly, west-southwest winds that are taking place here. So right away, just looking at this, I can tell that the thunderstorms will be rather fast-moving as they move from generally west-northwest to east-southeast. And not only that, but we're also seeing a fairly dry mid-level profile. We're seeing Cape values still hovering around 1500, possibly up to 2000 joules per kilogram. So anything in between those two curves represents instability or Cape. And this amounts to, at this time anyway, around 1500 joules per kilogram. So that's pretty high for the late evening. And the other factor I want to bring to your attention is the 500 millibar temperature. So we're seeing approximately, if you follow this diagonally down, so we're seeing a temperature of approximately -5 Celsius, right? At about 500 millibars. So this is not a particularly cold profile altogether. So what this tells me also about the character of thunderstorms is that lightning frequency may not be particularly high in this situation, despite the very high humidity. So a dew point value of about 74 Fahrenheit. So that's still very high humidity at this hour. And that's really what's guiding a lot of this instability. But the 500 millibar temperature is not particularly cold. So I think the lightning frequency is not that it'll be low, but I think there'll be more of a restriction on how high the lightning actually gets in terms of frequency. So I'm willing to go for about moderate lightning frequency with these thunderstorms as they propel themselves quite quickly to the east-southeast and southeast in general. But I think the primary hazard with these thunderstorms will be the damaging straight-line winds, and I wouldn't rule out an isolated weak tornado earlier in the evening due to these veering components that we're seeing in the boundary layers. So that's another thing to pay attention to. At the same time, I think hail production will be very limited in this particular case since we have, again, a fairly warm 500 millibar temperature. So putting all this information together, uh, really what I think in terms of the target area would be something like this. So following this red zone that I'm trying to create here, so approximately something like this. So pretty much from Quebec City all the way southwest to Windsor, Ontario. The risk will be most important in southern, southwest Ontario during the afternoon of July 24th, and then that risk will start to migrate towards the east and northeast during the later part of the day, July 24th, into predawn, July 25th, when lift starts to really become more aggressive in eastern Ontario to southern and southwest Quebec and portions of upstate New York. So this area here, I think, will be the most important to watch for July 24th into early July 25th. Now, the primary hazard, as I mentioned, would be the damaging straight line winds in this zone, especially in eastern Ontario to southern Quebec when those thunderstorms really start to merge more aggressively into small bowing segments within that broader thunderstorm family that eventually forms by later in the day ahead of that shortwave trough and the cold front. Those are our two important lifting features. So ultimately, because of the behavior of the thunderstorms, I do expect at least scattered thunderstorm coverage. So this will be, I think, the thunderstorm behavior altogether. Now, there will be also a narrow window of opportunity for a weak tornado in eastern Ontario and western Quebec right before these thunderstorms really start to adopt a more straight line wind hazard. I also did mention that lightning frequency would be moderate at best, as we saw 500 millibar temperatures are not really all that impressive to provoke higher lightning frequencies, although a higher lightning frequency is possible with some of the more organized thunderstorms, but I suspect it would only be sustained for a brief period of time. But in general, I think moderate lightning frequency at best is doable. Now, flash flooding is not too much of a concern in this situation because of our fast thunderstorm movement. So thunderstorms will be moving quite fast in this sort of direction, a little bit in this direction as well. So something like this. So that doesn't mean that the rainfall won't be heavy. It is actually quite heavy, mostly because of our very humid environment. But it's just that this rainfall is not sticking around in any given area for an extended period of time, like we saw, for example, on July 13th. So, nonetheless, torrential rainfall is very likely with some of these thunderstorms, so we have to watch that as well, and that must also be taken seriously. Finally, hail production should also be limited, mostly because of our 500 millibar temperatures being restrictive, so that shouldn't be too much of a hazard, although small hail is still a possibility in the zone. So if you made it this far, thank you very much for your attention. I really appreciate you reaching this far if you managed to stick with it up to this point. So I hope that the video was insightful for you. It's intuitive, it captures information that you were probably interested in, the behind the scenes. But ultimately, if this is of interest to you, feel free to subscribe so you do not miss out on upcoming videos. I do post videos like this much more regularly for thunderstorm situations and perhaps other extreme weather situations, for thunderstorm documentations altogether for the Montreal area and also the Orlando, Florida areas. I will leave some updates in the comment section below as the situation evolves because there's still new data to come, so just bear in mind that the situation can change a little bit here and there, the timing, the hazards altogether, so look out in the comment section below for that sort of update. And until then, I will see you in the next video. So thank you once again, and cheers.